your question. If not, remind me of it when I get to the end. But we're starting off with number 5 on limits. Wait, this isn't limits. This was a question, though. That was yours, huh, Jack? Okay, whose did I miss before? Lorenzo, you had a question before this. What was it? Limits, what number? I think someone else had a question before Jack, too. Why did it disappear? I think I had your basic derivative one. Yeah, I got that one. Huh. Okay, let's just go through what we have, and then we'll see where we're at. So number 6 on limits. Let g be a continuous function on the closed interval 0 to 1. You guys don't have to pay attention to me, but if you're not, you're staying quiet, okay? G of 0 equals 1, g of 1 equals 0. Which of the following is not necessarily true? I know one y value and another y value. That sure sounds like IVT. I wonder if any of these have to do with g, a continuous function hitting everything between 1 and 0 on this interval. This one has to do with a value of g. Is 1/2 between 1 and 0? Yes, that's IVT. That's guaranteed. It says not necessarily true. Well, let's cross out C because that is necessarily true. There exists a number h such that g is equal to 3/2. Hold on. Isn't 3/2 bigger than 1? Is there any guarantee that I'm going to have any y values outside 1 to 0? Oh, there you go. I just looked for IVT. There we go. But hold on. How are all these other ones guaranteed? For all a and b, if a equals b, then g of a equals g of b. That's just talking about definition of a function. That's a little bit tricky, but it says function. So function for every x, there is one and only one y. That's true. So that one, just definition of a function, actually I can cross off. For the last one, for all h in the open interval, the limit as x goes to h of g of x is equal to g of h. Definition of continuous, yeah, the value is equal to limits. Definition of continuous, that one's true. And then letter A, there exists a number h such that g of h is bigger than all the rest. There is an absolute max. Yes, EVT, the function's continuous. D is the only one. Outside of the y values are not guaranteed by IVT. That is not necessarily true. Number 5. Ooh, I love this one. Guys, you should know this notation. I know it looks funny, but it's not talking about powers when it puts n. Not for the dny over dx to the n. Isn't this a derivative? So what if you take the first derivative? We actually had a test question similar to this when d cubed y over dx cubed is equal to dy dx when the derivative is the first derivative. Remember that one? Also, the trig one? I don't remember. It's like 1 and 3 or 2 and 3 or 1 and 2. Anyway. What's dy dx of e to the u? Well, how do I take the derivative of e to the u? E to the u times u prime. Isn't n just a coefficient? So what would the second derivative be? Just start taking derivatives and see if you can find a pattern. Because wouldn't it be e to the nx again times another n? What if I was doing the third derivative? Wouldn't it be e to the nx again, but now you have the original n and the other n and now another n? Isn't it n then n squared then n cubed and it matches whatever this is? Doesn't that look an awful lot like a? N to the n times e to the nx. E to the nx, e to the u is going to stay the same, but times another n, times another n, times another n, times another n. Love it. Number next one. Oh. Good thing they're not asking for points of inflection, because then we'd have to find the second derivative. This one's just asking for the first derivative. Is that hard enough for us? Yes. First derivative. What rule do we need? Guys, sometimes problems are hard just because they're hard. Sometimes problems are hard just because they're hard. Not impossible, but hard. Quotient rule. Do you think maybe I would rewrite this one to be x squared plus 8 to the 1/3 first? And 2x plus 1 to the 1/4? Yeah, I would. And then I would go ahead and start doing my quotient rule. The name of the game on this one is, can you do chain rule, quotient rule, and simplify? So here we go. I'm going to go ahead and go dy dx. Someone did this on the board. Mel, was this you and Maggie? Yeah. Bring down the 1/3. Keep the u to the negative 2/3 times u prime. Wait a minute. That's just derivative of the top. Ugh, what am I supposed to be doing? The quotient rule. Doesn't the quotient rule say bottom d top? Yeah. Okay, so you can't just go deriving the top, deriving the bottom. L'Hopital for limits. So bottom, I would have derivative of the top times the bottom, 2x plus 1 to the 1/4. I apologize for the order there. Bottom d top, got it, minus top d bottom. Bring down the 1/4 times 2x plus 1 to the negative 3/4 times 2. U prime. This guy squared. 2x plus 1 to the 1/4 squared. Whoever asked this one knew what they were talking about. Green trick. 2? Oh dear. Well, that's not so good. So what am I going to do? We have options. If you want to follow Maggie's way, you would say, forget the simple, because this is a problem that I don't mind scary stuff because it gives me a number. Why not just go plug in right now? If you want to follow Aryan, you can go through and make that thing as pretty as you want it to be and then plug in. But what could happen in the midst of making it pretty? You could mess up. So, I don't remember exactly how Maggie said it yesterday, something about get away from me, Satan. But basically, I don't know what she said. Plug in 0 would be my advice. But first of all, Abby, do you have a question on the derivative, kid? It's a 1/4, and I kept on writing it worse and worse and worse. Because I brought down the 1/4 power. Does that make sense? Whoops. We're glad you made it back. Okay. I know, but guys, it was a great hint that you just got, not just for the final, but also for the AP. Plug in now. So when you plug in now, okay, hold on. Well, do you love yourself? Yeah. You going to make it pretty? Not pretty, but at least something you could understand? So couldn't I put the 2 times the 0 on the top, but this little guy, the negative 2/3, would pop that down to the bottom? Can we at least rewrite like that? And that is times 2 times 0 plus 1 to the 1/4 minus. All I did is put the stuff with positive exponents on top and then the stuff with negative exponents on bottom, and whoever's on the bottom stays on the bottom. Over here, I'm going to do something similar in that I see 2 is on top and x cubed plus 8 to the positive 1/3 is on top, but 4 is on the bottom and 2 times 0 plus 1 to the 3/4 is on the bottom. And then I have 2 times 0 plus 1 to the 1/4 squared. Now you might be like, that's disgusting. And maybe it is. But question, isn't this just 0? Isn't 0 times anything just 0? Over here, isn't that going to be 8, and 8 to the 1/3 is going to be the same thing as 2 times the cubed root of 8? Question, what's the cubed root of 8? 2. What's 2 times 2? 4. So I'm going to end up with 4 over 2 times 0 is 0. 0 plus 1 is 1. 1 to any power is 1. And 1 times 4 is, well, looky there. Now on the bottom, 2 times 0 is 0. 0 plus 1 is 1. 1 to any power is 1. And 1 to any power is 1. Whoo! Final answer, negative 1. Dun, 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 A. What, Hannah? Sorry. Oh, it's another 4. Yeah, because 1 times 4. Yeah. Okay. You can slow me down and watch the video this weekend. Whoo! Number 12. It's a word problem. It's 1 of 2 categories probably at this point. The volume of a cone of a radius. Okay, they give me a volume formula. I see that. That's important. True. The radius and the height are both increasing. Wait a minute, the dimensions of this are increasing at a rate? Who is optimization? Is there anything to do with max min? It's related rates, right? Related rates. What we want to do, get this to look as mathy as possible and not as wordy as possible. Why am I going to write given dr dt equals dh dt equals 1/2 centimeters per second? Where on earth did I get that from? the radius. Sorry, derivative applications, the really long title. Number 12. Where am I getting this from? The radius and the height increase at a rate. dH dt dr dt equals 1/2. At what rate? Doesn't that sound like a question, like I'm supposed to be finding it? In cubic centimeters per second. Ooh, you already know that's a volume. Cubic centimeters. Is the volume increasing? They just helped me out. We didn't even realize back then that increasing was another word for first derivative. Interesting. When the, such that, height is h equals 9 centimeters and the... Oh, guys, look, it's right there. All I did is translate. What? But what were we supposed to do? Find a derivative of what? Of him with respect to t, implicit differentiation. Do I need to go get that in terms of one variable? No. They gave me so many clues about all of them, I can keep them all. How can I keep them all? Because I'm taking ddt, not ddx or ddy or ddr or ddh. I'm doing ddt of not just one side, but both sides. Now careful. When you take the derivative of 1/3, no stress, he's a coefficient. Pi, no stress, he's a coefficient. R squared, no stress, it's one variable. H. What rule do we need? Product rule. Derivative of v is dv dt. All right, product rule second. H. D first, 1/3. Wait, d first. I need to bring down the 2, right? So, second, h times d. Derivative of the first, bring down the 2. So 2/3 pi r. What can't I forget? What can't I forget? Who do I do before I finish the product rule? R prime, dr dt. Remember implicit differentiation? When the variables don't match, I need the u prime, which is a dr dt. First, d second, derivative of h is dh dt. Remember these guys? Do you guys want to do the green trick or just go plug it in? It's up to you. I don't care. Yeah, you can just plug in. Why? Think Maggie Corey. If you try to simplify, you might make it wrong. True? You have a 9. Can't I plug in a 9? He's going to go in there, and that's it. I have a 6. Can I plug in a 6? He's going to go there, and he's going to go there. Wait, don't I also have a dr and a dht that can go both there and there? I already have it all. Plug and chug. So h is equal to 9 times 2/3 times pi times r is 6 times dr dt is 1/2 plus 1/3 pi r is 6 squared times 1/2. Woo! Circle it. You're done. Well, you do have to simplify a little bit, yeah? Well, that's all right. 3 goes into 6, 1 and 2. 2 and 2 is 4. 4 and 9 is 36 pi. Ooh, but what about my divided by 2? Well, 36 divided by 2 is 18. Careful. Get all your pieces. The 2's end up simplifying too. 2 times 9 is 18 pi. Who's going on over here? What's going on over here? 6 squared is 36. 36 divided by 2 is 18. 18 divided by 3 is 6. 18 plus 6, 24. P.S. On YouTube videos, you can slow down, not just speed up. Next one. Sorry, help me out. MVT? Is it? This one's derivative applications MVT. Derivative applications MVT. It's the other derivative applications page. Let f be a function given by. What are all the values of c that satisfy the conclusion of MVT? Do I have to go writing a paragraph about whether or not MVT applies? No, just use it. There's none of these. MVT applies. Okay, cool. Plus he's a polynomial. He's continuous and differentiable anyway. But pause. Do you realize they did not tell you what MVT says? You need to know it. So what does MVT say? As long as all the conditions are met, there is an f prime of c. I'm going to put an x such that f of b, which my b is 3, minus f of a is 0, all over 3 over 0. The c's are the x's that work in this equation. Within the interval. The c's are the x's that work in this equation within the interval. Wait, this equation, what's going on? Oh, well, I know 3 minus 0 is 3. How am I going to do f of 3? Don't I have an f? Can't I plug in 3? Now, some of you, careful. Wasn't there a test recently where some of you plugged in and did not get them to match when they should have matched? Rolls through. Be careful when you plug in. F of 3 is equal to 3 cubed minus 3 times 3 squared. Isn't that 0? 27 minus 27? F of 0 is equal, well, I know that one, 0 minus. F of 0 is equal to 0 minus 0, which is 0. Oh, sweet, I guess the answer is 0. It's right there asking for you to choose it, and yet, is it wrong? Yes. Only one part of the equation is getting the right-hand side. Who's supposed to be on the left? The derivative. So shouldn't this be 3x squared minus 6x? Couldn't I factor that to be 3x times x minus 2? Wouldn't I get x equals 0 and 2? Now pause. What's my interval? 0 to 3. Is 0 allowed? No. Why does c equal 2? Because MBT says for all values c within the open interval a to b. C is not allowed to be 0 because they're only allowed to be inside or in between open interval. Point of inflection, how close did I get? Oh, I'm so close. I'll keep taping, that's all right. Even if the bell rings, just quietly leave so you don't mess up the video. But you can check it out later. Guys, I'll be here during period 7. I'll be here after school. I'll be here Monday after second period final. I'll be here Tuesday after second period final. What are you doing on Wednesday? Coming with pencils, erasers, final reviews, hopefully all the way done, well, halfway done, each side. Coming in early to get some breakfast. It'll be good, I promise. And getting set up and ready to go. Just don't eat too much breakfast. A, share, and B, you might fall asleep if you eat too much. Right? And don't forget to study for the calculus final. Guys, you may not leave my room until I have your test folder. I'm pausing the video, but all right, kiddos, the last 2 questions that you guys asked me that I did not have time for in class, I'm going to go ahead and cover right now. So as we're looking at this function, oh, I see 2 coefficients missing, a and b, but they did also tell me a point of inflection at 1, negative 6. So let's see what's going on. Point of inflection, I know second derivative. So I'm going to go ahead and find the first derivative, 3x squared plus 2ax plus b. For y double prime, I'm going to have 6x plus 2a. Ironically, the b cancels out, and that's the guy I'm supposed to be finding. But if there is a point of inflection of a polynomial, it's impossible for this linear function to not exist. So points of inflection can occur at zeros or dNEs of the second derivative. This thing can only be 0. So I'm going to go ahead and say, okay, to be a point of inflection, it had to be a pip first. The second derivative has to equal 0 because a dNE is not an option for this type of function. But they didn't just tell me a point of inflection, meaning set equal to 0, but also where it happens. So I know that x has to be 1 when this point of inflection happens, and f of x has to equal negative 6. Or I should say f of 1 equals negative 6. So therefore, I can go ahead and plug into the second derivative at x value of 1, because according to the description of a point of inflection, concavity changes at a 0 or dNE of the second derivative. So at 1, this must be 0. And if I solve for a pretty quickly, I can, by subtracting 6 and dividing by 2, get a to equal negative 3. But they didn't want a. They wanted b. So, well, we have used this clue as far as the point of inflection, the second derivative has to equal 0. And we used the clue that x equaled 1, so we ended up actually using both of those clues. Now, just because there's information in a problem doesn't necessarily mean that we always need to use every single piece, but it is interesting that there is also this other part to the clue, the y equaling negative 6 when x equals 1, that I haven't used yet. And so I look and say, well, tell me anything about the second derivative value. That doesn't really tell me anything about the first derivative value. But that does tell me something about the y value. Oh, I can set y equal to negative 6 when x is equal to 1. And now that I know what a is, instead of putting a, I'm going to put what he equals, which is negative 3 times 1 squared plus b. I still don't know, but I do know x. And all the equation in terms of 1 variable, we should be able to solve. Quickly finish that up. We will end up with 1 squared is 1 times negative 3 plus b minus 4. I apologize, not plus 4. And so with some pretty quick calculations, I have negative 3 minus 4 is negative 7, plus 1 is negative 6. 0 is equal to b, and with that I can finish off problem number 7. That's what they wanted. The last example, number 2. What are the coordinates of the inflection point on the graph of? This one was actually super similar to one of your guys' test problems that probably a lot need to do corrections on. Ooh, actually, you know what? I think it was similar to a problem in period 1's version of a test. Maybe not yours. But either way, it's a good one. Period 1 still asked about it, even though they'd seen something super similar. So here we go. Inflection point, we just talked about. We need the second derivative. Second derivative, well, sometimes you just got to do what you got to do. And right now I see the product rule, and it's the only way to go. The only way to go. So therefore, here we go. Y prime, got to get to y double prime, is equal to second arctan of x. D first, derivative of x plus 1 is just 1, plus first x plus 1. Be careful of those parentheses. D second, derivative of arctan. That's one of those random rules you should make sure you have down. 1 over 1 plus x squared times u prime. Well, u is just x, so that's not very exciting, just times 1. We are going to have to do y double prime. Maybe just a few of you, it might be nice to rewrite this a little bit prettier. But yes, you are going to have to do quotient rule again when going to y double prime, because we have to have y double prime for anything to do with concavity or inflection points. So therefore, y double prime. Nice thing is arctan, there's no product rule this time, so just his derivative, 1 over 1 plus x squared plus quotient rule time. Bottom, 1 plus x squared. D top, just 1, minus top, x plus 1. D bottom, 2x, all over bottom squared. At this point, thinking about points of inflection and thinking about needing to find the zeros or the DNEs of that second derivative, a common denominator to make one fraction would be ideal in so many ways. And so therefore, my advice would be common denominators, like it has been ever since talking about points of inflection. Derivative simplified, remember? So we're going to end up with a 1 plus x squared in this first fraction, combining with the second fraction, the secondary, because now they both have common denominators. I'm going to go ahead and distribute just a little bit to make my life easier. So plus 1 plus x squared. I'm going to distribute some more, watching out for that negative, not killing a seal. So minus 2x squared minus 2x. When simplifying that second derivative, just don't lose track of what you're doing. We do end up with 1 plus 1 is going to be 2. X squared plus x squared, 2x squared will reduce, or I should say cancel, with the negative 2x squared. I still have a negative 2x chilling. Now we know for pips, it's time to go looking for zeros and DNEs. For zeros and DNEs. The zeros come from the numerator. Subtracting the 2 divided by 2, x equals 1 is one of my candidates for an inflection point. And the denominator, when I go setting equal to 0, maybe, just maybe, some of you guys end up realizing eventually we'll get to plus or minus square root of negative 1, which is not real, but will not be present in our real number system. So we can go ahead and just say none. Our one possible inflection point is 1. If you guys look at your answer choices, there's no none of these. So according to our math, we're pretty sure it's 1. You could just go for D or E. We'll talk about how to know the difference between each of them in a second. But if you were trying to be safer than sorry, let's say you had a little bit of extra time, you were feeling really good on this one, you could go ahead and throw that 1 into a sign chart. Because to be an actual inflection point, it's not enough to just be a pip. There has to be a sign change. If there was an option of none of these, you definitely need to check because maybe it was possible but not actual. When I go to plug into my second derivative, and we left him up here, This is the guy I'll probably plug into. We want to plug in something less than 1, something greater than 1. 0 is easy and less than 1. 2 minus 0 is 2 all over something positive. You could double check that, but I will have a positive second derivative on the left of 1, on the interval negative infinity to 1. On the right of 1, plugging in 2, 2 minus 4 is a negative number. That denominator is always positive. So therefore, yes, there was a change in concavity. Yes, x equals 1 is not only possible, it's an actual. However, when they said up here, coordinates of, they're not just asking for the x, they're asking for the y. Be careful, be careful, be careful, be careful. Sometimes you have something like 1 comma 0, and you're like, oh, that's right, because the second derivative was 0. No, 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 no. In order to find the point, you need the x and the y. The x and the y would be 1 and 1 into the original function, coming way back up here. That would end up 1 plus 1 times arctan of 1. Unit circle, strangest times. Review, 1 plus 1, that's 2. Arctan of 1. If you're a cheater chart kind of person, it's pretty easy. Square root of 3 over 3, 1 square root of 3, which is pi over 4. Oh. But maybe you're not a cheater chart kind of person. Maybe you would need to think about when sine over cosine reduces to be 1, which is once again only at 45 or at pi over 4s. We end up needing to use pre-cal to finish the calc problem. 2 times pi over 4 is pi over 2. That's the y value to finish off my point. And dun, 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 dun. Ah, nope. Careful. Done. I think that's E. It's really tiny. All right, bye guys. Happy studying.